Hi, I'm going to be showing you how you can find example projects and import them easily into VS Code extensions and specifically using MCC. Now we'll be looking at the MCC Melody content library. There's a separate video on that for Harmony. Okay, so going to Discover, we can come into Code Examples, MCU, MPU Examples, and here we have the content type. So bare metal is no MCC at all. MCC Classic is a bit older, and then we have Harmony for ARM, PIC18-Q43 SAM devices, etc., and then MCC Melody for PIC and AVR and some DSPICs. Okay, so we're going to filter on MCC, and I have this Curiosity Nano Explorer with this lovely I2C bus running all along, and I am going to therefore look for a project with I2C, and I'm also going to filter on a device family. So if we type AVR, we get a lot of the newer AVR families. Many of these have very similar peripherals, and so should be reasonably easy to port projects from one to another. There's a video I've made porting from one board to another board with Harmony. Those principles would apply here in a similar-ish kind of way. If we filter on Q, we can see a lot of the more recent PIC18 devices, Q71, Q10. We're going to filter on Q43. So at this point, we have a number of different filters added. If we click Advanced Search, we can see that ANDs have been added in here, and we can see that the search supports and/or operators, and if you want more details, you can click here for tips and tricks with Discover. Okay, so now we're down to 11 projects. You don't necessarily expect as many for all the different families, but let's have a look. We have Proximity, Lead Chaser, IO Expander, and here's an interesting one. Find all clients on the bus. So this one here, an I2C write is attempted on all possible I2C client addresses to identify clients responding with an ACK. Then you send a printf message, and you can see that that's at 115.200. And you can see that all these errors, NACK, and then every now and again you get an ACK, error none, and you can see that 10 devices are found. So let's see if we can replicate this. Download. Okay, so coming into the folder with the project, we can see a .x. This is originally from MPLAB X, and we copy the path, and we can open folder, paste, select our folder. So now we can expect that at installed MPLAB that there's a project importer here. And sure enough, do you want to import this project? Yes. And now we have the files here, and note that there's a build running as well, and we see the terminal output, and we can see that the code has been built. So we can immediately run it, run in debug, MPLAB debugger, Curiosity Nano, project opens, halts at the beginning of main. Just make a note here, this recommended CC++ extension. So if we go to our extensions, this Clangd, which is our language server for code completion, navigated insights, that is what we recommend instead of this one with MPLAB. Okay, so we're going to free up space at the bottom and the side, and we are going to open the MPLAB data visualizer. We can see our kit detected. We have a default baud rate of 115. We're going to put this as text on the terminal, clear up some more space here, and run our project. And yeah, so there we can see all the NACKs and some of the no errors, and we find 10 devices. So this all seems to have worked pretty well. One more note on the Curiosity Nano Explorer, that if we go to the top and search for Curiosity Nano Explorer. We also get a hit here under evaluation boards. We can open the user guide, and just coming into I2C, you can see the full bus and all the details here. And next to any of these items on the bus here, the temperature sensor, you can see a little home icon, So that comes here, and we can dive into any of these items on the board very easily. So great job by the hardware team there on the documentation. Yeah, enjoying playing with VS Code, and in the next video we start a MCC Melody project from scratch and cover a lot of the things that you'll need to know as you start working with MCC in VS Code extensions. Thank you.